Everyone, and welcome to lesson 3.2. Today we are going to talk more about transformations and our second type of rigid transformation called a translation. Now, our translations, again, are rigid motions, and so they will preserve the length of our sides as well as the size of our angles in our figure. And what a translation does is it's basically a slide of our figure to the right or to the left or up and or down. Now, our translations, again, are rigid motions. They're going to keep the size and shape of the original pre-image to the image. And when we talk about moving up, down, left, right, we represent that with a uppercase T. And then the first thing we write in there is a letter that's going to represent the horizontal movement, a number. So for instance, 3 means 3 units to the right, -3 would mean 3 units to the left. And then we would represent it with the vertical movement. So for instance, 4 would mean 4 units up, -4 would mean 4 units down. So that's our notation to represent our translations. So we see here we have triangle EFG, and we are translating it to be E prime, F prime, G prime. And notice our rule is telling us that we are taking that and translating it 7 units to the right, 4 units down. So we count 7 units right, 4 units down to map each of our figures. Now you can also use that without a graph. You can always add, in this case, the 7 to each of the original X values to get our new corresponding image X value, and then we would subtract 4 from each of the original Y values to get our new Y value. So what we can see here is we could take these original, if we're going to take our original points of E, F, and G, so -5, 4, -1, 5, and -2, -1, what we would do is we are going to take, in this particular case, we're going to move to the right 6 and down 7. So you're adding 6 to each of your original X values, and you would be subtracting 7 to show the vertical movement down 7 to get our new point. So again, E prime, F prime, and G prime are new points. If we add 6 and subtract 7, we would be at 1 comma -3. -1 minus, or excuse me, plus 6 is 5, minus 7 is -2, and then G prime, add 6, we would be at 4 comma -8. Right. The second one we want you to try on your own. You can move to the right 11 and up 2. Now, we also want to be able to write our own translation notation. This one we want to move to the left 6 and up 19. So again, horizontal movement comes first. Left would be represented with a negative. Up would be a positive value, in this case, 19. There is now example 1B for you to try on your own. Now, graphing wise, we always want to take our originals and make sure when we graph it that we label our new image points. So this rule is telling us to move to the right 4 and down 2 on each of our values. So if we look here, we're going to take each of our points E, F, and G. E moves to the right 1, 2, 3, 4, down 1, 2, 3, 4, 5. Oh, sorry, 2. Gosh, what am I doing? Down 2. So we have E prime. And then we also have F prime moving to the 1, 2, 3, 4, down 2. So we have F prime, and then G prime would be moving to the right 1, 2, 3, 4, down 2. And what we notice about this is that our figure E prime, F prime, G prime is the same shape and size as the original. The next example is asking you to translate to the left 3 and up 5. Again, be sure to label your new image. Now, part 2 here, example 2, is asking us to be able to look at the picture and be able to write our new rule for our image. Now, a reminder, your pre-image is always, like in this case, STUV, without the apostrophe. So we know that the black would represent the pre-image, the red is representing our image. And notice if we count, we went to the left 1 and then down 1, 2, 3, 4 units to show our rule, left 1, down 1. So translation rule representing that. So if we look at example P, P is our original. We would have to move this to the right 1, 2, 3, 4, 5, up 2. So again, a giant T, right 5 units, and up 2 units to represent that value. All right, final example on this page. Notice they are telling us we have an original point here of V, and it is being translated to be this new point V prime. So again, V is the pre-image, V prime would represent our image. Now what we're noticing is to make that movement, we would have had to add 3 to the X values, subtract 1 to the Y values to get our new image value. So if we are going to use that same exact rule, we want to now find what the image of point E is. So again, point E originally is at -3, 8. And again, we would have to add 3, subtract 1 to get our new point. E prime is going to be at 0, 7. You are going to now try the rule for number 2b, and then also find the image of point L. Our last part of these note is talking about a composition of rigid motions. Now, what a composition of rigid motions does is it does 2 or more rigid motions in a row. So in this case, they are first translating. Notice we go right to left, and then we are reflecting. And we can then come up with a final image. You take the translated points and reflect them. So you use your first image and then create a second image from those points. So in example 3, they are telling us they want us to reflect first over the y-axis and then translate to the right 4 and up 4. So we're going to start here with the reflection over the y-axis. So notice we are 1, 2, 3 points from the y-axis on the right. We will be 3 from that on the left. 1, 2, 3, 4, 5. And then we have to count 5 the other side. And then finally 1, 2, 3, 4. Count 4 to the other side. Here is our intermediate image. This is again our reflection of L, M, and K. These points again are moving over here. We're at -3, 1. We are at -5, 0. And we are at -4, 3. Now from there, our final image again is asking us to translate this to the right 4 and up 4. So we're going to take each of these and move them to the right 4 and up 4. So L prime ends up at, or excuse me, double prime because we moved it twice, ends up at 1, 5. M prime, we move 1, 2, 3, 4 to the right, 4 up. M double prime, and because we've moved it twice now, is at -1, 4. And then last but not least, K double prime, move to the right 1, 2, 3, 4, up 2, 3, 4. Here's K double prime. Again, this is at 0, 1. So again, we use that intermediate image to help us graph that final image point. Thanks everyone for watching. We'll work more with this in class.